Computer. All right, happy Wednesday. We have 5 weeks left. That is 15 Calculus 1 courses. That's all you, Calculus 1 meetings. That's all you've got left, 15 of them. Counting today. So really only 14 because this one's almost over, right? Friday, your homework is due. On the video on Monday, I talked about what is an optimization problem, what are the 5 steps to solve it. We did some examples. What were the 5 steps? Remember?
Yes, draw a picture.
Draw a picture. Make a formula. Write it in terms of one variable, right? That's the difference between related rates and optimization is that you have to make it in terms of one variable. In related rates, we didn't have to do that, right? Okay, number 4, take the derivative. And number 5, find your answer, right? Check your endpoints, see which ones are the max and min. So when you're reading a word problem and you want to know, should I solve this as a related rate problem or should I solve this as an optimization problem? How are you going to know? Like what words are you going to look for that are going to tell you this one should be a related rates problem, this one should be
Time closest.
Largest and smallest.
largest and smallest would mean what kind of problem? Optimization, maximum and minimum. What kind of words did we see in the related rates problem that said to us, we should find a rate here? According to time per, how fast is it changing, right? Like you should think about changing, those are going to be rates, maximums and minimums, closest, farthest, most. Those are the words that you think about for optimization, okay? Okay, I changed this problem. I sent a notification yesterday. I don't know. I'm sorry. I apologize if you had printed already. So here is, if you need to write, I'll give you a chance because I changed it. An island is 2 miles due north of its closest point along a straight shoreline. Visitor is staying at a cabin on the shore that is 6 miles west of that point. The visitor is planning to go from the cabin to the island. Suppose the visitor runs at a rate of 8 miles per hour and swims at a rate of 3 miles per hour. How far should the visitor run before swimming to minimize the time it takes to reach the island? Oh, no. Let's see if it works. It does. Okay. How far should the visitor run to minimize the time? So we are looking for the minimum time. So in our equation, we should be looking for an equation that deals with time, right? Because that's what we're trying to minimize. Okay, let's draw a picture. I have an island. Here's my shoreline. I have an island over here. This distance straight from the island to the shore is 2 miles. This is my island. Let's see if I should make it green. All of the rest is water. What color is the water like that? Water, 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 water. Okay, they're on a cabin. Shoot, the cabin is west. Darn. Okay, here's the cabin. You guys are particular about it having doors and windows. Okay, there's my cabin. This is 6 miles west, not minutes, miles. Okay, more water over here. Water, 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 water. Okay, there's a person at the cabin. And the person is going to run along the shoreline. That's their running. And then at some point, they're going to decide to jump in the water and swim the rest of the way to the island. Okay, so the person is going to run along the shoreline, then they're going to jump in the water and swim to the island from that point there. Okay, everybody understand what's happening? So there's some running happening, run, and there's some swimming happening, swim. I don't know how far they're going to run though, right? It says, how far should the visitor run before swimming to minimize the time it takes to reach the island? So there's some distance here. I'm actually going to call this guy X, the distance here on the triangle, because it makes my life easier. And then if this total distance is 6 miles, And this distance on this bottom part of the triangle is X. How far do they run? How far is this running distance here? If the total distance from the house to the directly below the island is 6, this is X, this is how many? 6 minus X miles, okay? So the amount of distance that they run is 6 minus X miles, yeah? And the amount of distance that they swim, I don't know what it is, let's call it S. Swim, call it S. S for swim. Okay, so the run distance is 6 minus X, and the swim distance is S. Okay, 1, draw a picture. 2, make an equation. What am I needing an equation for? Minimum, what am I trying to find? Minimum time, right? So I need an equation for time. Minimum, oh Lord. Time, okay, time equals, the time is going to be the time to run plus the time to swim, yeah? If I know the distance, and I know how fast they're running and swimming. Do we know how fast they're running and swimming? Yeah, they're running at 8 miles an hour and they're swimming at 3 miles per hour. So they run a distance of 6 minus X at 8 miles per hour. They swim a distance of S at 3 miles per hour. If you know your distance, and you know your, what is this, 8 miles per hour, what would you call that? Your speed. If you know your distance and you know your speed, can you find out your time? Yeah, how? Let's write down something that we do know. Okay, speed is in miles, distance per hour, time, yeah? If I want to get to time, new color. If I want to get to time, how do I solve for time? Distance over speed. Time is distance over speed. Yes, multiply both sides by time, divide both sides by speed. Yeah, so time is distance over speed. Okay, so the time it takes me to run is going to be the distance I run. What's the distance I run? 6 minus X over the speed I run. How fast am I running? 8 miles per hour plus, good, the distance I swim, S, over the speed I swim, 3. Yeah, 3 miles per hour. So this is going to be my time equation. What's wrong with this time equation? I've got too many variables, right? I need to eliminate one of the variables. Let's go back to our picture. What do you see in the picture that might help you eliminate one of the variables? A right triangle. You see this triangle here? Okay, 3. My helper is going to be that triangle. Is this right triangle? X, S, and 2. What equation can you set up from this right triangle? Pythagorean theorem. Yep. X squared plus 2 squared equals S squared. Okay, so this is X squared plus 4 is S squared. Remember, I need X because in the end, I want to find out how far they ran, right? How far should they run? That's okay. We're going to write S equals what? Awesome. And I'm going to replace it here. No, you can't do that. You can't do like square root of 6 + 5 and say it's square root of 6 + square root of 5, right? No, that's bad. Bad, 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 bad. You should lose a sticker for that. Well, now you're gonna have to get 2. Okay, what's going in for S? Square root x squared plus 4 over 3. Okay, at this point, we should talk about the domain, okay? We should talk about the domain. What does X represent in our picture? A distance here, right? X represents this distance right here. Can X be negative?
No.
You can't have a negative distance, right? Can X be as big as you want? No, what do you say? X cannot be more than 6, right? If X is 6, then they swim across the lake the whole time. Agreed? If X is 6, this triangle gets really big. They swim across the lake the whole time. If X is 0, what happens? They run all 6 miles and then they swim 2 miles across, right? So the domain of X is somewhere between 0 and 6. Why is domain important? Because what am I trying to do? I'm trying to find the minimum. I need the endpoints, right? When I find absolute minimums, I check my critical points and I check my endpoints. Okay, how do I find critical points? Find where the derivative is 0. All right, let's take the derivative of this guy. 4. I think that's 4. I can't remember. Okay, derivative of that guy. I think we should rewrite this guy before we take the derivative. Let me take that prime away for a second. I'm going to rewrite this guy as 6 over 8 minus 1 over 8x. Everybody okay? Yes, plus 1 over 3 times x squared plus 4 to the 1/2. So I took this first fraction, 6 minus x over 8, and I broke it into 2 pieces, 6 over 8 minus 1 over 8x. I took this second fraction, I made dividing by 3 the same as multiplying by 1/3. I made the square root the same as a 1/2 exponent. Now it's easy for me to take the derivative, right? Before I was like having to think really hard. Now I don't have to think hard anymore. Okay, derivative is derivative of 6 over 8, 0. Minus derivative of 1/8 x, 1/8. Okay, plus 1/3 times derivative of x squared plus 4 to the 1/2, 1/2 x squared plus 4 to the negative 1/2 times 2x, because I need the chain rule, right? Where the stuff inside my square root is not just an x. I have to do the chain rule to take the derivative of that guy. Okay, I'm going to do a little bit of simplifying because what do I want to do with this equation? Make it equal to 0. To find where the critical points are, I want to make this equal to 0. 0 equals negative 1/8 plus. What I notice is that this 2 cancels out with this 2. Yeah, this negative 1/2 means put it in the denominator and make it a square root. So in the numerator, I have an x, and in the denominator, I have a 3 square roots x plus 4. Okay, how will you solve this guy? Add the 1/8?
Yeah.
Add the 1/8, okay. So add 1/8, I gotta put more space in. Okay, I'm gonna add 1/8. And then I could just cross multiply. Yeah, that's kind of like getting a denominator, I think. I'm gonna cross multiply. So I get 3 square roots of x plus 4 equals 8x. Okay, now what? Okay, I could do that, sure. Square roots of x plus 4 is 8x over 3. Square both sides, okay. X squared plus 4 is, when I square this side, I get 64x squared over 9. Subtract 4. I don't like denominators. I try to never have denominators. I would multiply everybody by 9. 9x squared plus 36 is 64x squared. So I multiplied everybody by 9, so I wouldn't have any more denominators. And then subtract 9x squared. It's a quadratic, right? So since there's only one x, I can try to get them together. 55x squared. Divide by 55. X squared is 36 over 55. So x is square root 36 over 55. Do I need the negative square root? Because, yeah, remember my domain was that x had to be a positive number, right? So I don't need the negative square root. Square root 36 over 55. I got 0.809. Okay, that was a lot of algebra, right? Up here, when I got to this equation, 0 equals this stuff, what could I have done? So I don't have to use any algebra. When I got here, 0 equals this stuff, what could I have done? Man. Yeah, put it into your graphing calculator or to Desmos. Why can't I get over here?
He said that Friday.
And he told you no, he told me about that, yeah. He was like, I told them they couldn't do that. I was like, okay, fine. So I had -1/8 plus x over 3 square root x squared. Oh God. Plus 4. I'm looking for where it's 0. And that's right there at 0.0809. So our critical point, yep, is x equals 0.809. So what 3 points do I need to check? 0.809 and 6. Where am I checking them?
You're plugging in.
What am I looking for? I'm looking for the distance that will minimize the time. So where should I check these numbers? In the time equation, right? I should check these numbers in the time equation. The number that gives me the highest is going to be the maximum. The number that gives me the lowest is going to be the minimum. So I'm going to take these 3 numbers, I'm going to plug them into the time equation. Let me write down the time equation again for you. It was 6 minus x over 8 plus square root x squared plus 4 over 3. Yeah, was that the time equation? Okay, so I'm going to take those 3 numbers, I'm going to plug them in my time equation. 6 minus x over 8. I'm putting my time equation in Desmos. X squared plus 4 over 3. Okay, I put my time equation in Desmos. I'm computing t of 0. I'm computing t of 0.809. And I'm computing t of 6. Let me screenshot that and put it in. Oh, no, I can just write it down. Okay, so I put my time equation into Desmos. There it was, my time equation into Desmos. I computed what happened at 0, what happened at 0.809, and what happened at 6. And these are the numbers I got: 1.42, 1.37, and 2.11. So I got 1.42, 1.37, and 2.11. So 1.42, 1.37, and 2.11. Time is in what units? Hours. Yeah, it was in, because our thing was in miles per hour. Hours. Okay, I'm looking for which one? The minimum. Okay, so if X is 0.809 miles, it takes 1.37 hours to get from the cabin to the island. Okay, I'm going to scroll back up to my picture for a second because I want to make sure we actually answered the question. Right? I don't think we did. I think we have close to an answer, but I don't think we have the whole answer. So if X is 0.809 miles, it takes a minimum of 1.37 hours to get from the cabin to the island. Okay, this says, here's my picture, right? Here's my picture. How far should the visitor run before swimming to minimize the time it takes to reach the island? Yeah, because remember, the distance that they run is 6 minus X. So if X is 0.809, then the distance that they run is going to be 6 minus 0.809 miles. Okay, so down here, I'm going to say they should run 6 minus 0.809 or 5.1. Can't do that. 1,000 minus 809 is 191. 191 miles. And then swim. Yeah. I mean, it's the only calculus method, right? You could try to graph it and just see where it goes. But, you know, it's not going to get you any calculus points. Okay, so what we're going to do today is I have 6 board problems. I'm going to break you into groups. I think there are 1, 2, 3, 4, 5, 15 of you. Okay, I'm going to break you into 5 groups of 3. And we'll just do 5 of them, okay? And then I'll do 1 at the end. So let's break into 5 groups of 3. Tatiana, you want to come to this group? Yes. They have a group. This group. Yeah. 3. What is it? Yeah. And 3. Okay. Jason, you're gonna be in this row here. Okay, you guys can pick first. What do you want? 2. Okay, number 2 is taken. All right, you guys over there can pick next. 6. They want number 6. Okay. You guys, which one do you want? I think we'll take
2.
I don't know.
Which ones are taken?
2 and 6 are taken.
Wait, which one are we? 4.
4.
That's good. That's too bad. They didn't get to pick.
You can't pick 2, 4, or 6. Which one do you want?
1.
1. You guys want? You can pick 3 or 5.
Oh, I definitely picked that. You want the big one or you want the fence one? Huh? Absolutely. 5. Okay.
Pick 5 then.
5.
Yeah. All right, you guys are going with 5. Okay. Okay, everybody remember your number?
Sure. Let's work that.
Okay, let me give you some markers. You can work on your paper first and then put it up. I gotta pause the recording. Yeah. Okay, the margins are to be 1.5 inches. Up here at the top, there's 1.5, down here at the bottom, there's 1.5. On the sides, it's 1 inch. So over here, there's 1 inch, over here, there's 1 inch. There's writing in the middle, okay? There's writing in the middle. It says, what should the dimensions of the page be? So dimensions are length and width, so that the least amount of paper is used. So I want to minimize the area of the paper. What's an equation for the area of the paper? Length times width. Yes, length times width. I need one variable to happen here. So I need a helper. What do I know? What didn't I use yet in this problem? 24 square inches of print. If this is L and this is W, how big is this thing right here, inside here? The area of the writing is 24. Can you find the area of the writing in terms of L and W? Yeah. Okay, here's what I'm going to do. I'm going to say call this L and this W. Yeah. So then here, I'm going to say L times W. What's the area of my paper now? If in here, this is W, how big is it from here to here? W plus 3. You did the W, how much writing there was, plus the 1.5 on top and the 1.5 on bottom, right? So W plus the 1.5 on top and the 1.5 on the bottom. It's kind of like your rectangle make a box problem, right? So this is going to be W plus 3 times, how big is this distance here? Yeah, if this writing part is L, then I get 1 inch on the left and 1 inch on the right. So the total is L plus 2. Okay, I want to get rid of one of these variables. I'm going to use my helper to get rid of one of those variables. Let's solve for L. L is 24 over W. So here for L, I'm going to write 24 over W plus 2. I can from there take the derivative, or I can do some simplifying first. Doesn't matter. Okay, multiply it out. Sure. Okay, so I have to do W times this guy. I get 24. W times 2 gives me 2W. 3 times this guy is 72 divided by W. And 3 times 2 makes 6. So I FOILed this out. I did W times 24 over W, gave me 24. I did W times 2, gave me 2W. I did 3 times 24 over W, gave me 72 over W. And 3 times 2 makes 6. I'm going to do one more simplifying before I try to take the derivative, because I don't want to use the quotient rule. So I'm going to write that third term as W to the negative 1. Now what? Take the derivative. 0, 2 minus 72W to the negative 2 and 0. Yeah. Derivative of 24 is 0. Derivative of 2W is 2. Derivative of this guy is negative 72W to the negative 2. Derivative of 6 is 0. Okay, and then what do I do? Equal it to 0. Okay, I'm going to rewrite this right-hand side as 72 over W squared. Okay, so I have negative 2 is negative 72 over W squared. Multiply by W squared. Negative 2W squared is negative 72. Divide by negative 2. And W is square root of 36, or 6 inches. Let's talk about the domain of this guy. Make sure everybody has time to write. Do they tell us anything about like what W can be? Like I could make a really long skinny paper, right? Or I could make a really tall skinny paper. Yeah, there's no extreme on how big W can be. So this guy doesn't really have a domain. He's like an unbounded domain, right? So we're going to assume that the minimum area occurs when W is 6. I want to read the question though, because it says, what should the dimensions of the page be so that the least amount of paper is used? Is W a dimension of the page?
Yeah.
What's W in my picture?
Oh, it's
Oh,
the
no.
print.
W is the writing,
Yeah.
yeah? So what are the dimensions of the page going to be? If W is 6, then this is going to be 9 inches tall, W plus 3, 9 inches tall. And how am I going to find out this width here, this length here? With the equation. Which one? Okay, look, I know that 24 is L times W, yeah? So if W is 6, then L is 4. When W is 6, L is 4. So the dimensions of the paper are 6 plus 3 and 4 plus 2. 9 by 6. 9 inches by 6 inches. So even if the solving is easy, you got to think a lot, right? Like you got to do a lot of thinking about what happens. Okay, I'm in the AEC today until 3. I'm there again Friday after class. Friday is a question asking day. So I'm just going to answer any homework questions you have from optimization. See you then.